Hey guys, welcome back. We're going to look at 6.2, which is special triangles and solving trig equations. Now, it's almost the same stuff that you did in grade 11. The only difference is we're going to be working strictly with radians in this case. We're going to be converting what you used to know into stuff that you have been learning. So, in front of you, you should see the special triangles. Now, these special triangles you should be able to draw from memorization back from grade 11 when you use these. But what we're going to do is we're going to apply radians to them because you're probably used to drawing them in degrees, potentially maybe radians. But one thing that you might remember was when we dealt with degrees, we can convert them into radians by multiplying by pi over 180, which works out to be pi over 6. So in our special triangle, instead of 30 degrees, we have pi over 6. Same goes for 45. If I convert, I get pi over 4. So our special triangle becomes pi over 4 for the 45, 45, 90 triangle. And the last one, we have pi over 3. So another way of writing 60 degrees is pi over 3 if we have it in radians. So that's what our special triangles will look like with radians. Now we know how to get our exact values for them. We have 18 numbers that we should be able to get here. And I know that you look at these and say, well, sine, I know that's opposite over hypotenuse. And if I look for the pi over 6, which is the triangle on the right at the top, opposite over hypotenuse is 1 over 2. Cos, you can continue through, is adjacent over hypotenuse, which is root 3 over 2. Tan is opposite over adjacent, which is 1 over root 3. But you might remember that when we work with fractions, usually we don't have a rational number on the bottom like that, or root 3. So we call rationalizing the denominator. So we multiply the top and bottom by root 3. So it actually becomes root 3 over 3. So both those ones are fine. It's just a matter of, usually we don't write a denominator with a root on the bottom. For cosecant, well, that's just sine flipped. It's hypotenuse over opposite. So if it's 1 over 2, cosecant is 2. Secant is cos flipped, so that would be 2 over root 3. And if I rationalize that denominator, it's 2 root 3 over 3. And cotangent is tan, just flipped. So originally it was 1 over root 3. So when I flip, it becomes root 3. And I'll just go fast here to get the rest of them. But
45, using the triangles on the left, sine will be root 2 over 2. Cos also root 2 over 2. Tan is going to be 1. Cosecant is root 2. Secant root 2. And cotangent is also 1. And finally, we have root 3 over 2. And 1 over 2. Root 3.
so we have these 18 values that you should be able to get from your special triangles that you already know. The only difference is now our special triangles was written with radians, but same thing, 45 degrees is pi over 4. 30 degrees is pi over 6, and 60 degrees was pi over 3. Those are ones we're going to be familiar with going forward. So that being said, how does that apply to our Cartesian grid? Now, we know the cast rule that says CAST, which ratios are positive in which quadrant. So for example, if I had a terminal arm in the second quadrant here, I know that the second quadrant is between 90 degrees and 180. So if I had a value like sine of 120, that's in between, I know that that's going to be positive because the S in sine tells me that that it's going to be positive in that quadrant. Cos of 120, so in that quadrant as well, negative. And tan in that quadrant is also going to be negative because only sine is positive. That's what the cast rule says. Now, what about their reciprocals? So what about cosecant? Well, cosecant, although it starts with a C, it's the reciprocal of sine. So if sine is positive, well, the reciprocal, if I flipped it, it'll still be positive. Secant is the reciprocal of cosecant. So if cosecant is negative and I flip that fraction, it's still going to be negative. And same with cotangent. If I flip that original, it's going to be negative. So it's a matter of not the first letter of the reciprocals. Instead, we're just looking at the first letter of the original functions to figure out if it's positive or negative, and that's going to lead us to the reciprocals as well. So one thing that's a little bit different here is that we're going to no longer work with the radians. I'll use blue. With the degrees, we're going to work with the radians. So if we think about our terminal arm, this will be starting at 0. Well, if I know 0's the start and halfway around the circle is pi radians, well, what's half of that? Well, that'll be the distance here. That'll be pi over 2. And I know if this is pi radians, down at the bottom must be 3 pi over 2. And over here will be 0 or 2 pi. So each 90 degrees is like 0.5 of a pi, if you want to think of it that way. So that's one way that we can work with it. Let me just erase these ones. So another way that you can think of this would be, well, 0 here. As I go here, this will be 0.5 pi. As I continue through, that'll be 1 pi. This will be 1.5 pi, or we said 3 over 2. This will be 2 pi. As I continue around, it's also 2.5 pi. Terminal arm over here will be 3 pi. Down at the bottom, 3.5, 4, 4.5, 5, 5.5, and so on. So you kind of get the idea of how they work. Normally we're going to write them as fractions. However, that's kind of the way that we see them. So when you're using your calculator to work with radians, you have to make sure you know what mode we're in. So your calculator is either going to be in degree mode or it's going to be in radian mode. You should be able to convert between the two. You might have to Google for your own calculator how you would convert between the two, but normally you're going to see at the top capital D or capital R, which will tell you what mode you're in, because if you're inputting radians, you got to make sure your calculator is in radian mode. If you're inputting degrees, you got to make sure your calculator is in degree mode. So that being said, let's look at some of these examples down below, putting these numbers into our calculator. So if I have sine pi over 2, how do I know that that's radians? Well, there's no little degree sign that we have at the top. We just have that pi over 2, which tells me that we must be working with radians. So if my calculator is in radians, I can put sine pi divided by 2, and we should get the value of 1. Same goes for tan. If I'm putting in tan, -5, tells me that I should have 3.38. Next one, we have a fraction. I should be able to put in a fraction, right? I can put cos. I might have to open up a bracket, but I'm going to put 3 pi divided by 4. And we should get a number like -0.707. And lastly, we see cosecant 2.25. And we might say, well, I don't know how to put cosecant in my calculator. I don't have a cosecant button. Most don't. But keep in mind, cosecant, if you have something like cosecant x, that's equal to its reciprocal, 1 over sine x. So cosecant 225 is equal to 1 over sine 2.25. So I can put that in my calculator, 1 divided by sine 2.25, and we should get 1.28. And those are the values that we end up with, making sure our calculator is in degree mode, right? Because this number here, like pi over 2, is a very small number, right? It's like half of pi, which is a very small number. So it's like if you have it in degree mode, your calculator is going to think you're working with 1 degree, which is quite a bit different than when working with radians. So what I want to do is use a sketch to determine which quadrant these terminal arms lie. So we're working with radians with these ones. So cos 5 pi over 6. So you might say, well, how do I figure that out? What I'm going to do is I'm going to draw grid. I know that we have 0 over here and we have pi over here. 5 pi over 6 is less than that, right? 5 over 6 is smaller than 1. So I know it's going to be less than pi. It's also bigger than pi over 2, because pi over 2, if I had a denominator of 6, would be 3 pi over 6. Well, 5 pi over 6 is bigger than that, so I know it's in that second quadrant. So it's going to be in this quadrant here. Next, it says also find out the related acute angle. So remember, the related acute angle is the angle that's created right in here. So I'm looking for the related acute angle. Well, it's got to be the difference between pi and 5 pi over 6, where this one ends, right? I'm looking for the difference. I'm looking for the section that's in between those two. So when I subtract those ones, pi over 6. Normally the denominator is going to give it away a little bit as to what the related acute angle is going to be. We have 6 on the bottom here. I could get 6 over 6 and subtract them, but the 6 kind of tells me quite a bit about it. Same goes over here. I see a 4 as my denominator. That might be important to me, but let's check. Sine 5 pi over 4. So I know, once again, I'm going to put the same thing on here. Zeros here, pi's over here. 5 pi over 4. So 5 over 4 is bigger than 1. So you know it's going to be on this side. How far on that side, I'm not sure. Down here we have, well, 1.5 pi. I know that. Or 3 pi over 4. We can think of it, 3 pi over 2. You can think of it that way. Both are the same. So 5 pi over 4, maybe I look at it and say, well, that's 1.25 pi. So that's bigger than 1. That's less than 1.5, so I know it's got to be in this quadrant here. Whoops. So I'm looking for the related acute angle. I know it's in quadrant 3. Related acute angle is going to be the angle that we have right here. So how do I find that? Well, if we have pi here and the angle is 5 pi over 4, I'm looking for the difference between 5 pi over 4 and pi. So I'm going to subtract those ones. So our angle is 5 pi over 4. Take away pi. I can get common denominators, but that's just going to work out to pi over 4. That's our related acute angle in this case, pi over 4. That's that purple angle. And we'll look at the last one here. Same idea. Cotangent 5 pi over 3. The denominator gives away quite a bit, as I told you. If I want to graph this one, well, I'll do the same thing. I'm going to put, I know zeros here. I know pi is over here. I know that pi over 2 or 0.5 pi is here. I know that 3 pi over 2 or 1.5 pi is here. When I look at 5 over 3, well, that's bigger than 1 pi. I can divide them, and I know that works out to be like 1.666 and continues on. That's bigger than 1.5, which is at the bottom. It's less than 2 pi, which is the full circle. So that tells me it's got to be in the fourth quadrant. So if it's in the fourth quadrant, we want to find out what the related acute angle is. Related acute angle, as we know, is always created with the x-axis right here. So I want to find out what's the difference between 2 pi and 5 pi over 3. So I'm going to subtract those. 2 pi alpha is equal to 2 pi minus 5 pi over 3. Alpha is equal to pi over 3. That's our related acute angle in this case. That's that alpha angle is pi over 3. So that's the first part, is being able to determine what quadrant we lie in and also what the related acute angle is for each ratio that we have. So let's take this idea and apply it to the next one. It says, for the following points lie on a terminal arm in standard position. Sketch the angle and determine the radius and calculate the principal angle in radians. So let's think about this. -6 and 3. Well, that's 6 to the left. So 1, 2, 3, 4, 5, 6, and up 1, 2, 3. I have a dot somewhere around here. And I know that my terminal arm is going to pass through that one. So I'll draw the terminal arm maybe in orange. So this point was at -6 and 3. So great. So we sketched it. Next, we want to find out what is the radius. I want to know what's the distance of the orange line from the origin to here. We'll call that R here. Well, what we can do is think about what -6 and 3 is. Well, -6 is the distance to the left. 3 is the distance up. So we see a triangle that we have here. We have 3 up and 6 to the left. That's so we might see a triangle here with one side being 3, one side being -6, and one side being R. You can think of that 6 as being positive 6. But what we're looking for is R. So in that triangle, we're dealing with the hypotenuse. So we're looking for R squared is equal to 3 squared plus negative 6 squared. Right, it's the Pythagorean theorem. It's a right angle triangle right here. So when I put them into our calculator, 9 plus 36, add them together, r squared is equal to 45, and when I root them, we get 45. That tells me that the radius, in this case, is root 45. That was the second part that I asked us for, the radius. And finally, the last one says, determine the principal angle. So the principal angle, let's use green. Principal angle is the starting one, this one here. That's the principal angle. So what am I going to have to do? Well, I can't find that out right now. What I'm going to do is find out the related acute angle and then subtract that from 180, because that will tell me what's left over for the whole top. So now that I have all three sides of that triangle, I can use any ratio to help me find that. You can use sine, cos, or tan. In this case, probably easiest on this triangle here to use tan, because opposite over adjacent, then we don't have to work with any roots. So I know back from grade 10 that tan of the angle is equal to the opposite over the adjacent. In this case, I'm going to treat it as 6 because we're dealing with that angle. If we do negative, it's going to switch for us. So just think of it as being a triangle. That's 3 and 6. And then from there, I'm going to bring tan over to the other side. We know that we get tan of negative 1, 3 over 6, or half. Tan of negative 1, 3 over 6. Put it into our calculator. I get 0.463. And that's in radians because we're calculating radians. My calculator was in radians. If it was in degrees, you might have a different number, but the question wants it in radians. So from there, what do? Well, I can take this number, which is the angle that we have right here, and subtract it from pi, because pi is one full circle. So our principal angle must be equal to pi minus 0.463. Put that into our calculator. Pi, remember, is 3.14 minus 0.463, and we get 2.68. That's our principal angle that we're working with. I should probably do that one in green because it was green on the picture. And that's how we find that one. Had I put in the negative 6 here, all that would happen would this be a negative radian, and you'd have to change that one. All right, this one wants us to state the equivalent expression to this. So I want to know, what is equivalent? Cos 7 pi over 4 is equal to cos what value? There's always two ratios that are equal to each other over the course of one full circle. So for example, this one here, 7 pi over 4 is going to be in the fourth quadrant with a related acute angle of pi over 4. So what we're going to do is find out where else will cos 7 pi over 4 have the same expression. So if I think of my cast rule, cos is positive down in this quadrant. Where else is cos also positive? Cos is also positive in the first quadrant. So that means that our equivalent expression must also be in the first quadrant with the same related acute angle. In this case, pi over 4. So if pi over 4 is a related acute angle, in the first quadrant, well, the related acute angle is the same as the principal angle because it is already between the x-axis and the terminal arm. So that's equivalent to cos pi over 4. These two are the same. If I put these into my calculator, I'm going to get the same value. So if I put in my calculator cos 7 pi over 4, I get positive 0.7071, which is the exact same thing if I put in cos pi over 4. They're equivalent expressions to each other. They give us the same value. There's only two that will give us the same value. So what does that mean, really? Or why does that happen? If you think about the graph of cos, starts at 1, goes down to -1. Basically, it's saying cos pi over 4, well, that's 45 degrees. It's somewhere around here. If you think of it that way, or pi over 4. It has a y value associated with it. And we found out that that was at 0.7071. It says, where else does that happen? So if I go across and down, it happens to be at 7 pi over 4, or that's 315 degrees. Both have the same y value, both at the same spot on the graph, right here and right here. That's why there's going to be 2. You know, there'll be 2 everywhere, like 2 here and here, if you thought of it that way. Let's kind of use the same idea for this second one over here for tan. I want to find out equivalent expression for this. It's going to be tan something. So let's find out where 11 pi over 6 is. So on our grid, 11 pi over 6 is also in the 4th quadrant. It's down here. It has a related acute angle of pi over 6. So based on our CAST rule, C-A-S-T, our expression of tan 11 pi over 6 down here is negative. So where else would I get a negative value if I put in tan to my calculator? Well, the other spot will be up here in the 2nd quadrant, because in the 3rd quadrant tan's positive, in the 1st quadrant tan's positive, so it's got to be in the 2nd quadrant. So I'm going to draw a terminal arm in that 2nd quadrant. Whoops. With the same related acute angle. Remember, the related acute angle is always with the x-axis. So pi over 6. So our equivalent expression must have an angle of pi over 6. So let's figure out what that's going to be. So that's our green one. So it's starting here, it's coming around. I want to know what is the angle for that. So I know that pi is here, but we're less pi over 6. So for my related acute angle, or my principal angle, sorry, is equal to pi minus pi over 6, which is 5 pi over 6. So that tells me that tan 11 pi over 6 is equal to tan 5 pi over 6. Because remember, 2 quadrants are going to be positive, 2 quadrants are going to be negative. This one we found out that the terminal arm was in the 4th quadrant, which gave a negative value for tan. So it must the equivalent must be in the 2nd quadrant with a negative value for tan, with that related acute angle of pi over 6. And we'll keep going here. This one asks us to determine the exact value. So here we have to do a little bit of work. The exact value means it's equal to, root 3 over 2 or something. We don't know. We don't put it into our calculator because it says exact value. If it said find an approximate value, sure, you can put that in your calculator. But this wants an exact value. So we treat it the same way what we've been working through. We find cos 3 pi over 4. Well, that falls in the 2nd quadrant. I'll use red because we've been using red. I know that pi is halfway around, so our related acute angle must be the difference between those. Our related acute angle is pi minus 3 pi over 4, which is pi over 4. As I said, usually the denominator gives you a lot of information as to what the related acute angle most likely will be. So that means that we're trying to find out the exact value of cos 3 pi over 4. So first thing we're going to do is figure out the sign. We're going to break it down to two things. It's either going to be a positive or negative. Whoops. And then we're going to deal with what the actual value is. So in the second quadrant, we know that CAST, I know that in the second quadrant, this expression of cos 3 pi over 4 must be negative because sine is the only ratio that's positive there. So I'm going to say it's going to be equal to negative something. I don't know what that something is going to be. However, I do know that it's equal to the related acute angle of pi over 4. So I'm going to try to find out what is cos pi over 4. Well, from our special triangles that we know, I'll put it on here in case you forgot. This is the 45-degree one, 1 root 2. Cos pi over 4 is root 2 over 2, or 1 over root 2 rationalized, which is root 2 over 2. So that's the exact value of cos 3 pi over 4. I had to break it down into two things. I needed to find out the sign based on what quadrant it was in. Once I knew that, I found the related acute angle of the same ratio. Right? So essentially what we were doing was finding out negative cos pi over 4. Cos pi over 4 was root 2 over 2, and the negative stayed. So let's try that on the next one. You'll see it's kind of the same steps we follow every time. If we're looking for sine 5 pi over 3, maybe the denominator gives us some information. In this case, 5 pi over 3, that lies in fourth quadrant. I know that 2 pi is all the way around. 5 pi over 3 is not quite 2 pi. So the related acute angle is the angle that we have in here. So it's the difference between 2 pi and 5 pi over 3. So related acute angle is 2 pi minus 5 pi over 3, which is just pi over 3. That's our related acute angle, pi over 3. So now what I want to do is find out this sine 5 pi over 3. What sign is it going to have? Well, based on the cast rule in the fourth quadrant, only cos is positive. So I know that this is going to be negative. Sine is negative in that quadrant. Only cos is positive in that quadrant. Then I want to find out, well, what's the fraction going to be? Well, a fraction is going to be same ratio, sine pi over 3. That's what I'm trying to find out. Sine pi over 3. It's the negative version of that. So I'm going to make my special triangle. Oops. Remember your special triangles. Pi over 6, pi over 3. Pi over 3 is the bigger side, so its side is root 3. We have 2 and 1. So for pi over 3, its opposite is root 3. Its hypotenuse is 2. So I can put that into our expression. I know that it's going to be negative root 3 over 2. That's the exact value of sine 5 pi over 3. It's negative root 3 over 2. Right, sine opposite over hypotenuse. It's negative because it was in quadrant 4. All right, and for the last one here, it says determine the radian value. So I'm trying to find the angle that we have here. So we have a little bit of information. It says cos of the angle is equal to negative 1 over 2. We know that based on the cast rule, that our terminal arm is either going to be in the second quadrant, because that's where cos is negative, or in the third quadrant, because that's also where cos is going to be negative. Now, from there, what we're going to do is figure out what are our values of the related acute angle, because if I can get that related acute angle here, it'll be the same related acute angle here. I'll be able to get the principal angle, because remember the principal angle would be this number as well as this value. So I need those related acute angles in order to calculate those. So how do I get those related acute angles? What we'll do first is I'll just work on the top one. If we zoom in, so if cos is negative 1 over 2, well, remember what cos is. Cos is adjacent over hypotenuse. So that would tell me that this side's got to be 2. And 1 has to be negative because we're going one spot to the left. And I can make this triangle here. So if I want that related acute angle here, I know this side here of the triangle is 1 or -1. And I know the hypotenuse is 2. So adjacent over hypotenuse, I can use cosine in order to calculate that. So I'm going to use purple here. Cosine of that angle that we're looking for, our related acute angle, is equal to adjacent 1 over hypotenuse 2. I can bring cos over to the other side. I can put that into my calculator. Which is 1.04. Or 1.05 if we rounded it. That's in radians. So that would tell me that this value here, underneath the angle, I'm going to put that in there for us. Is 1.05. So if I'm trying to find the principal angle, which is this one here, I know that it's going to be pi, which is the full half of the circle, minus 1.05, which will give me that first principal angle at 2.09. The second one is going to be similar. As we had before, it was in the second quadrant. Whoops. Didn't realize I deleted that one. In the second quadrant with that same related acute angle, 1.05. So in this case, if I'm looking for my principal angle, well, it's gone all the way around plus 1.05. So there's a second possibility, pi plus 1.05. Remember, pi is just 3.14. If I put in that calculator, we would get 4.19. Those would be the two angles that if I put into my calculator as radians, would give me -1/2. And I'll show you a different way that you could apply it to the same idea. You could do the same thing with this one, but I'll show you a different way. Another way that we could work with this is find out one of our angles right away by saying, well, let's bring sine over to the other side. We've done this before. I know that I can take the inverse of sine right away. But one thing you have to keep in mind is this is just going to give us one of the angles. So if I put in my calculator the inverse of sine, 2 divided by √3, so what we can do for this one is just take sine and bring it over to the other side, just like we know how to do. We know that becomes the inverse of -√3/2. But one thing you have to remember is when I solve this, all I'm going to do is get one of my values. I'm not going to get both. So what I'm going to have to do is use this one in order to help me get the other one. So here I get -1.05. So what does that mean here? Well, if I think of my grid, I know that 1.05 is down 1.05. It's going to be in this first quadrant with a related acute angle of 1.05. Happens to work out the same. Remember, it goes down because it's a negative angle, goes clockwise. So it happens to work out to be the same number here. However, you'll see where it's a little bit different. Now, in this case, I know that our cast rule says sine is negative in this quadrant. And that's right, we got a negative value up here. That's proper. Where else is sine going to be negative? Well, it's going to be in the third quadrant as well, with a related acute angle of 1.05. So what I'm going to do is find the two principal angles associated with this. So the first principal angle will be pi plus 1.05. The second one will be 2 pi minus 1.05. So we're going to get it in the fourth quadrant. And that's another way that we could get these ones. A little bit easier to get those values. But as we solve them here, we're going to get pi plus 1.05. Same as the other one, 4.19. However, this one happens to be in the fourth quadrant for the last one. So it's 2 pi minus 1.05, which gives us 55.23. And those are our angles that you can come up with. So either way is fine, but we get our answers that way. So that's this section. There's some questions down at the bottom that you can try in your textbook here.